Although ComFloor can span vast distances, a consequence of utilising this capacity is that larger deflections may occur, both in the ComFloor and the beam system due to the wet concrete load. The following points should be considered. Never heap concrete other than what is required to achieve effective screeding. Avoid shock loading the ComFloor. No matter whether a skip, boom pump or line pump is used, the concrete should be released no more than 300 millimetres from its final resting place. Spread the load evenly and you reduce the deflections on each side of the beam. It should be noted that the seesaw effect only applies where the ComFloor continues over both sides of the beam. Where the ComFloor joins on a beam is treated slightly differently. It's recommended that a 1 metre working zone is maintained to minimise local overloading. A good rule to start with is the 1/3 rule. That is, from each beam, one pours 1/3 into each span, leaving the middle third of the span unpoured initially. The resulting empty 1/3 zone between the beam strips can then be poured, using the existing concrete as screeding guides. The exact width of the concrete strips over the beams versus the strip left unpoured will vary slightly from project to project, as the beam size, span, pre-camber and the ComFloor span will vary, but the basic principle will. To avoid this and achieve the minimum designed slab thickness, height indicators are best used along the beam. These can be either pads of concrete or height gauges fixed to the beam and is termed pouring to thickness. In theory, any pre-camber in the beam should flatten once the concrete is poured. The pour is started as usual at one end of the building, but is broken up into bays. A bay is determined by the length of the individual ComFloor sheets. A strip of concrete is poured over the first secondary beam in from the building edge, using the 1/3 rule. Each secondary beam zone is loaded first, and then the gap between is filled. In all bays, the last section poured will be where the ComFloor sheets join on a beam, as these zones are the most prone to deflecting. Due to the great spanning capabilities of ComFloor, it's been found that ComFloor 60 is typically